Okay guys, so starting off with Unit 1, Lesson 1, we're starting off with just an introduction to functions, so we'll dive right into this. So what is a function? This is something that we've talked about, you've heard about it probably since middle school. But a function is a relationship where each domain is used exactly one time. All this means is that the x values do not repeat, okay? So don't let the words domain, range, all of that mess you up, okay? It just means x's and y's at the end of the day. So this notation is read as f of x, okay? So we can see it's got f, parentheses, x, and again we read that as f of x. And then we've got our domain. So again, guys, possible inputs are your x values. If I'm looking at a graph, we know that's the horizontal axis. Opposite of that is range. These are your possible outputs, which are your y values, okay? And these are the values that are covered in that vertical direction on the graph, so up and down, right? Then what we have what is called the vertical line test. So this is any vertical line can cross a function at no more than 1 point. We'll talk about what that means here in a second. And then that last vocab word means 1-to-1. So it is 1-to-1. What it means is that a function where each output is used only one time, so no repeating x's, also no repeating y's, okay? The way I like to think of functions is I like to think of functions as your x values being people and your y values being birthdays, okay? So again, if you need to write that off to the side, I would. So x is people, y is birthdays. So can one person have 2 birthdays? No, you can't, right? It's not possible. Every person is only born on one day. So therefore, a function, one person can't have 2 birthdays. One x value can't have 2 y values, okay? The opposite of that, though, is can 2 people have the same birthday? Yeah, they can, right? So one x value can't have 2 y values, but 2 different x values can match up to the same y value and still be a function, okay? And we'll talk about that with these representations here. Back to the 1-to-1 function thing, though. So again, people and birthdays. 1-to-1 function would be everybody sitting in my class right now, we all have different birthdays, okay? So no repeating people, no repeating birthdays, okay? No repeating x's, no repeating y's. That's just a good little visual if you get those two things confused. So looking at these representations, we've seen these before, mapping diagrams, okay? 2 little clouds that map onto each other. As we can see here, the 2 goes to the -1, the 4 also goes to the -1. The 5 just goes to the 2. So looking here, if we think x values are people, y values are birthdays, it looks like 2 and 4, again, 2 different people, have the same birthday or the same output of -1. Is that a function? Yes, it is, okay? Is it a 1-to-1 function though? No, because they both have the same output. We also can see functions represented as tables, okay? These are the same numbers as what we just went over. Same thing as points, and then also you can see things on a graph. We're going to look at these examples here. So are the following relations functions or not? And if they are they 1-to-1 functions? All right, let's dive right into that. Looking at the first one, is this a function? Well, if we think of people, birthdays, looks like 3 and 4 have the same birthday, but no x's are repeating in this. So yes, this one is going to be a function. Is it going to be 1-to-1 though? No, we just said it's not. 3 and 4 both have the same output. Okay, no x's repeated, that was good. Y's did repeat though, so it can't be 1-to-1. Number 2, this is where that vertical line test comes in. So what the vertical line test is I can draw a vertical line, again that means up and down, through any part of this graph. If it hits only one time, it is a function. If it hits more than one time, it can't be a function. Okay, we can see here, it doesn't matter where I draw that vertical line, it's only going to hit once. So this one is a function. However, is it 1-to-1? This is where it can get a little tricky. You got to really think hard and look hard at these graphs to know that. If I think about it here, I can see those 2 little dots I made. Those are just an example. So those are 2 different inputs, right? So this could be 1, this could be 3 on my x-axis, but they both have the same output. So they both are on the 0 on my y-axis. So therefore, can that be 1-to-1? Nope, cannot. All right, moving on, number 3, vertical line test. If I drew it right here, it would hit twice. If I drew it right here, it hit 1, 2, 3, 4 times. Whoa, definitely not a function. Can't be one-to-one either. And then we've got number 4 here. Let's just look at the values. If we need to draw a mapping diagram, we totally can. I see these 2 x's repeat, okay? So 2 is one person. It's got 2 different outputs, so 2 birthdays. Can't be a function, also can't be one-to-one. Looking at number 5, do I see any x's or any people repeating? No, that's a good sign. That means it's a function. And then, is it one-to-one? Are any of these y's repeating? No, so that one is also a one-to-one function. Good, hope you got the hang of that. Let's keep going. All right, operations with functions. So these are the different notations that we're going to see. We've got f plus g of x, which becomes f of x plus g of x, f minus g of x, which becomes f of x minus g of x. See how we're writing them separate? Make sure you just pay attention to these notations. F times g of x is f of x times g of x. And last one, f divided by g of x is f of x divided by g of x, okay? Lots of things going on right there. Don't get confused. We're going to talk about what this means. But first off, these little notes here, be careful with your negatives, okay? Make sure that if you are subtracting, you've got your negative in there, and it's being distributed. Same deal with multiplying, dividing. If you've got those negative numbers in there, it's going to change your answer, okay? So make sure you pay attention. Only add and subtract like terms, and make sure you write your answers in descending order. And we'll talk about that here as we get going. So, first off, perform the following operations using the functions here. So f of x is 3x minus 5. Okay, and g of x is x squared plus 2x minus 1. So first off, I have adding the 2. Okay, so f plus g of x is just going to be as that notation is written up here. So I'm going to do f of x, which is 3x minus 5, and I'm adding g of x. Okay, now I've just got to combine like terms to simplify and write it in descending order. What descending order means, start with your highest exponents first and then go down to your constants, okay? So first off, starting from left to right, my highest exponent is x squared. It does not have any like terms, so I'm just going to write it by itself. Next highest exponent is 3x. It does have a like term of 2x. Those become 5x. 3 plus 2 is 5. And then the last step are my constants. Negative 5 minus 1 is negative 6. And that is my answer. Okay? Next up, we have subtracting. So same thing, going to be using these same functions, but we are subtracting them. 3x minus 5 minus the whole function of g of x. So that is why I'm using these parentheses here. If I just put a negative in front of that x squared, I would only be subtracting the first part of that function. But I'm subtracting the whole thing, which is why I have to put the negative in the, or put the function in the parentheses after that negative sign. Parentheses mean to distribute, so I'm distributing out that negative 1. Becomes that. This 3x minus 5 just comes on down. And now time to simplify. Negative x squared is my highest exponent. Going to write it by itself. 3x minus 2x is just a plus x. And negative 5 plus 1 is negative 4. So that is my answer to number 2. Okay. Keep on going. We've got multiplication now. Okay, so same thing. Just going to write it as the notation says. We've got 3x minus 5. Going to go ahead and put that in parentheses because, again, it's being multiplied by that entire second function of g of x, which is x squared plus 2x minus 1. And how do I simplify something like this? It starts with an f. It is that word factoring, okay? If you remember how to do this from Algebra 1, go ahead and factor out that 3x to everything. 3x times x squared. 3 times 1 is 3. X to the first times x squared is x to the third. Remember, we add exponents when we're multiplying them together. 3x times 2x is going to be a plus 6x squared. And then 3x minus 1 is going to be a negative 3x. Next up, multiplying the -5 to everything. -5 times x squared is -5x squared. -5 times 2x is -10x, and -5 times -1 is +5. Okay, now time to simplify. We'll just start from left to right. Do I have any other x cubed? Nope. I have 6x squared minus 5x squared is just going to be a +1x squared. I have a -3x minus 10x is -13x. Good. And a +5 at the end. And that is my answer. I cross things off as I go just so I don't write them twice. It's a good habit to get yourself into if it helps you as well. All right, and then the last one is division. So we've got 3x minus 5 over our g of x function, which is x squared plus 2x minus 1. If you try to factor the bottom there, it actually does not factor evenly. So therefore, we're just going to leave this one alone like this, okay? So that's just going to be my answer. Normally, it'll simplify. This one doesn't, okay? Moving right along here. So now we can substitute a number or expression into a function and simplify as much as we can. Okay, so what this is, it's just the exact same thing, okay? But it's putting in a number for x instead of a variable, okay? So f of 2. All that means is that I'm putting in, normally we'd see f of x, right? So what I'm doing is I'm putting in 2 everywhere that it says x, but only in the f function, okay? Because that's what it told me. This is f of 2, not g of 2. At least not yet, okay? So f of 2 just means I'm going to put in 2. Hold on a second. I'm going to plug in 2. There we go. Everywhere I see x, which is just that one time, and then simplify. 3 times 2 is 6, minus 5 is just 1, and that's my answer, okay? Go ahead and pause here and try to do g. Okay, so g of -5 just means plug in -5 everywhere you see x in g of x. Okay, -5 squared is 25, plus 2 times -5, which is -10, minus 1. Simplify that. 25 minus 10 is 15, minus 1 is 14. And that is my answer on that one. All right, f of 3 of x, so 3 times 3x minus 5. You end up with 9x minus 5. Simple enough. G minus 2, so again, this is a g, plugging in this for x. X minus 2 squared plus 2 times x minus 2 minus 1. This little chunk right here tells me to factor, right? Remember this from Algebra 1. So I'm going to move this over so I've got a little bit more space. So x minus 2 squared is the same thing as just x minus 2 times x minus 2. Factor out the first x, we get x squared minus 2x. The next x, -2x plus 4. Simplify these, we can combine these middle terms. And that's as simple as it goes. So that became x squared minus 4x plus 4. Then I can distribute out this 2 to give me plus 2x minus 4. And then I still have a minus 1 at the end. And to simplify that, I only have 1x squared, so I'm just going to write it. -4x plus 2x is -2x. 4 minus 1 is just going to be -1. And that's my answer on that one. Keep on chugging along here. F times g of 1. So 2 ways we can go about this. You could go ahead and plug in 1 to each function and then just multiply those two numbers together, which is what I think the easiest way is to do. You can also just go ahead and solve out f of g of x, which we actually did above. Let me find it. This answer right here. If you went ahead and did all that work, got that, and then plugged in 1 to that, you would end up with the same answer. But the easiest way is just to plug 1 into f, plug 1 into g, multiply the two together. That's what we're going to do. So 3 times, hold on, f of 1 is just going to be 3 times 1 minus 5. Okay, 3 times 1 is 3, minus 5 is negative 2. We've then got g of 1. So g of 1 is 1 squared plus 2 times 1 minus 1, which just gives me 1 plus 2 minus 1, which is 2. So now I've got f, now I've got g, and I can just multiply the 2 together to give me negative 4. Easy enough. And then the last one, try this one on your own. F minus g of 3. That one's pretty easy. F minus g of 3. Okay, so what I'm going to do, plug in 3 to f. You get 9 minus 5, which is 4. Plug in 3 to g. You get 3 squared, which is 9, plus 2 times 3, which is 6, minus 1, which is 14. And then we're subtracting f minus g. What's 4 minus 14? Negative 10. That's my final answer. Okay. Let me know if you have questions on that. We're going to keep chugging along here. We're almost done with section 1. I know this section is pretty long compared to the others. Piecewise functions. So these are made up of different parts and pieces depending on the stated interval. So we have to look at the intervals given and find where the value fits and substitute that. So looking here at the very top, we've got this piecewise function, okay? Don't let this confuse you. It's not as hard as what it looks like, but I'm going to show you how to break these down. So what this is just one function, okay? But it's split into pieces. So for instance, piecewise functions are used in a lot of different real life aspects. For instance, tax brackets, okay? So depending on how much income you make is how you are taxed. So if you're making more money, you are going to be taxed differently than somebody who is making less money, okay? Pretty common sense, pretty straightforward on that. Other ways that piecewise functions are used. Let's say, for instance, you're renting a car. You're going to be charged based on the amount of time that you need that car for, okay? So you might get a discount if you need the car for 2 or 3 days, depending on if you just need the car for a couple hours, okay? They're going to have a different hourly fee for you renting that car. So looking at this piecewise function, this is how we write these. So what the top says, so f of x equals 3x minus 5 if x is less than 2, okay? Next part says f of x equals x squared plus 2x minus 1 if x is greater than or equal to 2. Okay, so depending on what x is what function we plug in the number for x. Okay, so looking at this top one, we've got f of negative 1. What I want to do here is negative 1 less than 2 or greater than or equal to 2? Well, I know it's less than 2. So I'm going to plug it in up top. Okay, so 3 times negative 1, plugged in negative 1 for x, and then subtracted 5. So 3 times negative 1 is negative 3, minus 5 is negative 8. Okay, go ahead and pause here and solve the rest. All right, f of 3. 3 is greater than 2, so I'm going to plug that one into the bottom. 3 squared plus 2 times 3 minus 1. That gives me 9 plus 6 minus 1. 9 plus 6 is 15, minus 1 is 14. Okay. Next up, we've got f of 0. Well, 0 is less than 2, so 3 times 0 minus 5 is just going to give me negative 5. And then we've got f of 2, which is equal to 2, right? So it's still going to be that second one. 2 squared plus 2 times 2 minus 1 is 4 plus 4 minus 1, which gives me 7. Okay? There can also be functions where there's more than one piece. So an example of this would be that x is, let's say, between 0 and 2. Okay, so x is greater than 0, but it's less than 2, it would be 3x minus 5. And then we had if x is less than or equal to 0 up here. Okay, so we could add more pieces. That might not be the best example there, but if you see more pieces, just know that that's okay, because sometimes there is just more than 2. Okay, composite functions, so this is substituting one function into another. Feel free to pause, take a brain break here. I know that this is a pretty lengthy section, but this is a super important part, so you need to make sure that you are present. So, composite functions, how we read these. These can get a little bit confusing, but make sure that you understand the notation and you should be fine. So looking at the first one, we've got f of g of x, and that is read as f of g of x. Okay, and then we've got g of f of x, and we read that as g of f of x. There's a little typo there. Okay. It is super important to realize that this little notation here, f open dot g, is just read as f of g of x. The way I like to write it is the second way, with f times parentheses g of x, because that tells me that I have my f function, I have my g function, but normally what I would have is something that read like this, f of x, and then let's say that I had f of 2. I would know to plug in 2 everywhere in f of x function that I saw x, okay? If I have now f of g of x, okay, all I'm doing here is I'm plugging in the g of x everywhere I see x in the f of x function. Okay, so it's no different than what we did before, except it's a little bit more complex. Okay, we just got to make sure we don't get the two functions confused and we'll be fine. Let me show you what I mean by this. So f of g of x is number 11. I'm going to rewrite it as this, because again, I want to see here that I'm plugging in g of x, so I'm plugging in this everywhere where I see x in the f of x function. So, g of x is right here, x squared plus 2x minus 1, and I'm going to plug that in everywhere where I see x in the f of x function, which is 3x minus 5, so this is what this is going to look like. 3 times x squared plus 2x minus 1 minus 5. So again, plugged in g of x into f of x. Okay? This notation confuses me. This one makes a lot more sense because it shows me what I'm doing. So use that second notation. Make sure you know how to change from the first notation to the second, but you should be good. Now I just got to simplify this out. I know that this 3 can be distributed. 3 times x squared is 3x squared plus 6x minus 3 minus 5. Combine like terms. My final answer is 3x squared plus 6x minus 8. Okay. Next up, we have the exact opposite, right? So this is g of f of x, which I can also write like this. Okay, so I'm plugging in f of x to g of x. How that looks is, let's go find f of x. It's right here. And I'm going to plug it into g of x. So 3x minus 5 is going to go in everywhere that there's an x in g of x. Now I know that this part can be factored. So 3x minus 5 squared is the same thing as 3x minus 5 times 3x minus 5. 9x squared minus 15x minus 15x hold on, I ran out of room. Let me rewrite this because it's hard to see. Okay, minus 15x minus 15x plus 25. Okay, combine like terms, this becomes negative 30x. Okay, so that's factored. I'm going to go ahead and write it over here. Then I know I can distribute out this 2, so this becomes plus 6x minus 10, and I still have a negative 1 at the end. And now to simplify. 9x squared, negative 30 plus 6 is going to be negative 24x. 25 minus 10 minus 1 is going to be 14. Okay. That is how we plug in g of x, or g of f of x. So we plug in f of x into g. Let me know if you have questions on that. I know these ones can get a little bit confusing, but as long as we're paying attention to those notations, we should be good. So let's go ahead and look at f of g of negative 2. So this is going to be very similar to what we did before. And I'm even going to write it a little bit different. So f of g of negative 2. Okay, so that's what we're plugging into the f function. Okay, same deal. So what I need to do is just find g of negative 2 first. And then that's going to give me the value to plug into f. So I'm going to plug in negative 2 to g. Negative 2 squared is 4 minus 4 minus 1. I end up with just a negative 1. Okay, so g of negative 2 equals negative 1. So now what I'm doing is just plugging in that to f, okay? Because I just found out that that equaled negative 1. So it just becomes f of negative 1. And we know how to solve that. Go up to f, it's 3x minus 5, so I'm just going to plug in negative 1. Negative 3 minus 5 is negative 8. All right, pause here and go ahead and try to do number 14 on your own. Okay. G of f of 1, to write it in a better notation, it would look like this. What is f of 1? Minus 5 is negative 2. So now I'm just going to plug in that negative 2 for f of x. So it's just g of negative 2, which is negative 2 squared plus 2 times negative 2 minus 1. Negative 2 squared is 4. Minus 4 minus 1 equals negative 1. All right. That is how we do composite functions. Let me know if you have questions. I know that's a lot. Feel free to rewind and go back if you need to. Okay? Now we've just got one more question left, and then we'll be good on this section. You take a taxi that charges a flat rate of $3.50 and 30 cents per mile. Write a function that shows the cost of the taxi. Okay, so this is a pretty good example of how we could use something like this in real life. So to write a function of this, it's just going to be c of x equals... Then I got to think about what my function is going to look like. So my information that I know, flat rate of $3.50, 30 cents per mile. So I know I'm going to have a variable, right? Because I don't know how many, I don't know how many miles I'm traveling. So to write this as a function, I need the amount I'm paying per mile, which is 30 cents, being multiplied by x or whatever variable. It actually tells me to use x, so I'm going to keep x there. So 30 cents per mile, so 30 cents times x, and then I'm being charged a flat rate of $3.50, which means it's not changing. So it's just going to be $3.50 by itself. Okay. How much would it cost to travel 13 miles? Well, I said x was miles, right? So all I've got to do on this one is just plug in 13 for x, so c of 13 equals 30 cents times 13 plus $3.50, and if you do that, you end up with an answer of $7.40. Last part here is just the letter C. If you had $16, what's the highest number of miles that you could travel? Think about how we could use that function if we just know how much money we have. So what we can actually do is if we know we have $16 and we know we're solving for miles, we can just plug in 16 for that c of x and then do 0.3x plus 3.5, or 350, sorry, and solve for x. Okay, so subtract that 350 over, divide by 0.3, you'll end up with x equaling about 41.6 miles. Okay, let me know if you have questions. That is the end of lesson 1.1. Homework is on Canvas. Make sure that you complete that. So thank you. I'll talk to you later.